Welcome to our video about callbacks in JAX. Today we'll explore how callbacks work and their different types. Let's start with the basics. First, we'll need to set up our environment. While you can use a CPU runtime for this tutorial, we recommend using a TPU v5e chip since JAX performs exceptionally well on accelerators. After connecting to our runtime, we'll install JAX and make sure to include the optional TPU components. Now let's understand what callbacks are. In simple terms, callbacks are a way to execute host-side code during runtime. By host, we mean the CPU host process, in contrast with JAX computations that would typically run on a GPU or TPU accelerator. To understand this better, let's look at a common example, printing a variable's value during computation. Imagine you write a simple function called f of x that tries to print a value. When you use this function with JIT, just-in-time compilation, you might be surprised by the result. Instead of seeing the actual runtime value you wanted, you'll get something called a trace time abstract value. This isn't what we wanted. If we try to fix this by removing the JIT compilation and using pure Python implementation instead, we'll get the intermediate value as expected. However, this isn't an ideal solution because just-in-time compilation is very important for JAX's performance, and we often want to use it from the beginning. Fortunately, JAX provides some helpful alternatives. For example, instead of using the regular print function, we can use JAX's special debug print function. When we modify our code to use debug print, we get exactly what we want. The intermediate value appears at runtime as expected. What's happening here is that the runtime value of y is being passed as a CPU array back to the host process where it can be printed properly. JAX actually offers several different types of callbacks, each designed for specific purposes. First, there are pure callbacks, which work well with functions that don't have side effects. Second, there's the experimental I/O callback, which is meant for impure functions. Finally, there's the debug callback, which is what powers the debug print function we just discussed. To help us understand when to use each type of callback, JAX provides a helpful reference table. This table shows us when our callbacks can return a value, when those will work with automatic differentiation, and more. Let's dive deeper into pure callbacks, which are the most commonly used type. A pure callback is what you should use when you want to execute purely functional host-side code, that is, code that doesn't have side effects. Side effects include things like printing values, reading data from disk, or changing global state. Pure callbacks work well with certain JAX transformations like JIT. However, to make them work with vmap, vectorized mapping, you need to provide a special vmap method. Once you've done this setup correctly, you can run vmap over your function f, pass it to your input x, and get the expected results. But there's a catch when it comes to gradients. Since we can't differentiate through the callback context, trying to compute a gradient will result in an error. While there is a way around this using something called JAX's custom JVP, that's an advanced topic we won't cover today. Another important thing to understand about pure callbacks is how the compiler treats them. Since they're considered to have no side effects, if you don't use the output of the callback function, the compiler might completely eliminate the callback. This means your callback might not run at all if its result isn't being used somewhat in your code. Now let's talk about the I/O callbacks. Unlike pure callbacks, I/O callbacks are specifically designed for impure functions, functions that do have side effects. To demonstrate this, we'll use a practical example with NumPy's random number generator. The NumPy random number generator is a good example because it uses stateful classes, making it impure. While this isn't the recommended way to generate random numbers in JAX, it's perfect for showing how I/O callbacks work. In our example, we create a vector that we want to fill with random numbers from a uniform distribution. Since we're using NumPy's non-pure random number generator, the I/O callback is exactly what we need. Just like with pure callbacks, you might run into challenges when trying to differentiate functions that use I/O callbacks. However, there's a workaround. If your callback doesn't depend on any differentiated values, you can still perform differentiation successfully. Finally, let's look at the debug callback, which has one key characteristic that sets it apart. It cannot return any value to your program. This limitation actually makes it perfect for certain tasks like logging or writing data to disk. The debug callback, which powers the debug print function we discussed earlier, is particularly useful when you just need to see what's happening in your code without affecting the computation. This is why it's such a popular choice for debugging purposes. One of the great features of debug callbacks is their compatibility with JAX transformations. You can use them with vmap to handle multiple inputs at once, and they work well with gradients too. This flexibility makes them a valuable tool in your JAX programming toolkit. When working with any of these callbacks, pure, I/O, or debug, it's important to choose the right one for your specific need. Here's a simple way to think about it. Use pure callbacks when you need to execute code that doesn't have side effects and you need a return value. Choose I/O callbacks when you're dealing with code that has side effects, like reading files or using stateful operations. Pick debug callbacks when you just need to see what's happening in your program without returning values. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include a link to the JAX documentation in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy it responsibly.